Welcome back, everyone. Today we're going to talk about costs and output of the firm. First, we're going to talk a little bit about the difference between short run and the long run for a firm. In the short run, it's just a time period when at least one input, like plant size or capital, it can't be changed. Plant size you can think of like the physical size of the factories that a firm owns and operates to produce its output, while long run is the time in which all the factors of production can be varied. Right, so managers typically of firms, they take into account both short-run and long-run consequences of their actions. While making decisions about what they do today, tomorrow, and next week, they keep an eye on the long-run benefits. A firm takes numerous inputs and combines them using a technological production process, right? And then they end up with some output. Typically, we classify production inputs into two broad categories, sometimes three, as labor and capital, and sometimes land. So here we have some production function, right? So it just says Q is output. We have some function of K capital and L labor. So production is any activity that results in the conversion of resources into products that can be used in consumption or in intermediate production. And the production function is the relationship between maximum physical output, which I'm just going to be calling output, and the quantity of capital and labor used in the production process. The production function is a technological relationship between inputs and outputs. So we want to talk a little bit about average product, which is very simply total product divided by the variable input, right? It's an average. So, and then there's marginal physical product or marginal product, which is the physical output that is due to the addition of one or more unit of a variable factor of production. The change in total product occurring when a variable input is increased and all other inputs are held constant, right? We've talked a little bit before about what marginal means. So we're kind of thinking about a hypothetical case of a production function and marginal product here. Here on panel A, we just sort of have an output schedule, right? On column 1, we have the input of labor. In column 2, we have total product. Column 3, we have average product, and it kind of reminds you how to calculate that. In column 4, we have marginal product. Here we have sort of a graph of total product. And here we have a graph of marginal product, and it kind of shows you something you may have noticed if you were looking at the schedule, right, the output schedule. So the marginal product of labor may increase very rapidly at the beginning because you're starting from no real input or no real labor. But beyond some point, the marginal product must begin to diminish as more workers are hired. This is not because additional workers are less qualified or not as good, but rather because each worker has, on average, fewer machines to work with. Maybe it gets crowded and people get in each other's way. And very similar to consumer theory, when we were talking about diminishing returns, we have diminishing marginal product. This is the observation that after some point, successive equal-sized increases in a variable factor of production, such as labor, added to fixed factors of production will result in smaller increases to output. So this is kind of an example. Consider production of computer servers, right, as an example of the law of diminishing marginal product. We have a fixed amount of factory space and assembly equipment and control and quality control diagnostic software, but the addition of more workers eventually yields successive smaller and smaller outputs, right? After a while, when all the assembly equipment and quality control diagnostic software are being used, additional workers will have to start assembling and troubleshooting quality problems manually. They may get slower. They're not as good as the software. They're not as fast as the software. The marginal physical product of an additional worker, given a specified amount of capital, must eventually be less than that from the previous worker. There's some point of saturation, some sort of bliss point. Given the amount of fixed inputs, there is no further positive use for more of the variable input. And here we have kind of an extension of what we were talking about before, but this is now talking about costs. And don't worry, we're going to talk about all the different costs that are listed here. But on column 1 we have total output, then 2 we have total fixed cost, and then total variable cost, and then just total costs in general, and then average fixed costs, then average variable costs, average total costs, and then what looks to be total costs again. That way it's easier to help you calculate marginal costs in column 9. And here we have sort of a graph of total cost and total variable costs. And notice total fixed cost is just this flat line, right? It's because it's a fixed amount, right? And here is a graph of marginal cost, average total cost, average variable cost, and average fixed costs. There's sort of a nice little connection between marginal cost, average total cost, and average variable cost that we'll talk about in just a second. So total cost is the sum of total fixed costs and total variable costs. Fixed costs are costs that do not vary with the output and are fixed for a certain period of time. It's like rent on a building. Variable costs are costs that vary with the rate of production, such as wages paid to workers and purchases of raw materials. And here we have at the bottom a little sort of formula for that. Then we have average total cost, which is an average of total costs. And we have total cost divided by the output. Average variable cost is much the same. And average fixed cost is, again, much the same. Marginal costs is the change in total cost due to a 1 unit change in the production rate. Right? It's marginal. It's additional again. The relationship between average and marginal cost. Remember I talked about it. I said there would be a nice little relationship between the two. When the marginal costs are less than the average variable cost, the latter must fall. When marginal costs are greater than average variable costs, the latter must fall. And you can kind of go and look back at that graph and sort of see this kind of relationship between the two. And you kind of have the same one between average total cost. Average total cost is equal to total cost divided by the number of units produced, right? So marginal cost is the change in total cost due to a 1 unit change in the production rate. So we have another sort of graph here, or table here, about, it seems, costs. And here's another graph of total product. And here's a graph of average product and marginal product. And here's average variable costs and marginal costs. And you can kind of see that relationship we were talking about right here. So now we want to talk about distinguishing between short-run and long-run costs. So firm short-run cost curves are a reflection of the law of diminishing marginal product. Given any constant price of the variable input, marginal costs decline as long as the marginal product of the variable resource is rising. And at the point at which diminishing marginal product begins, marginal costs begin to rise as the marginal product of the variable input begins to decline. So consider this: if the wage rate is constant, then the labor cost associated with each additional unit of output will decline as long as the marginal product of labor increases. So we want to now talk a little bit about long-run costs. So the planning horizon, right? The long run during which all inputs are variable, right? We talked before, we said short run is where there are some inputs like plant size, I think was the example, are fixed. Well, long run is we think everything is variable. So we have this long run average cost curve. It's the locus of points representing the minimum unit cost of producing at any given rate of output given current technology and resource prices. That's a lot of givens. Planning curve, right, is the long-run average cost curve. That's just really another name for it. So we have all these different in panel A, all these different short-run average costs, right? and they're kind of changing over time, and we've got C3 seems to be the minimum of the second one, and C1 seems to be the minimum of the first one. And then on panel B, we have sort of this long-run average cost curve, which is kind of this envelope of all the short-run average cost curves. And so we want to kind of think a little bit about economies of scale and constant returns to scale and diseconomies of scale. And just going back a bit, that's going to define different parts of the long-run average cost curve and different features. So economies of scale, this is an important idea. Decreases in long-run average costs resulting from an increase in output. These economies of scale do not persist indefinitely, however, and we're going to see that in a second. Once long-run average cost rises, the curve begins to slope upward. So you can think of economies of scale as sort of the more you produce, the cheaper in the long run your average costs become, but only for so long. And there's a reason for economies of scale. It could be specialization. You divide tasks or operations among different people or different objects, and they're slowly being allocated to their highest valued factor, right? There's a dimensional factor. You might have large-scale firms that often require proportionally less input per unit of output, or just improved productive equipment over time, right? And so we now have these different graphs. The part where it's decreasing, the long-run average cost curve is decreasing, is your economies of scale. The flat part is your constant returns, and the increasing part is diseconomies of scale. So I guess it's not really popping up, but the constant returns to scale is just, sort of an analog of diminishing, or of economies of scale. Long run or constant returns is just for every unit, right? If you were to double your inputs, you would get double your outputs. You'd get the same returns. Diseconomies would be if you doubled your inputs, you less than double your outputs. But for economies to scale, you double your inputs and you more than double your outputs. And you can kind of have the same argument for costs. So what is the minimum efficient scale? It's the lowest rate of output per unit of time at which long-run average costs for a particular firm are at a minimum. And it's this point at which you move from economies of scale to constant returns. It's just this point A here.